Hello friends. So this is a Harvard physics problem and this problem is called ladders envelope. So problem says we have a ladder initially that stands vertically against a wall and its bottom end is given a sideways kick causing the ladder to slide down. Assume that the bottom end is constant to keep the contact with the ground and the top end is constant to keep in contact with the wall. Describe the envelope of the ladder's position. So we have to find envelope of ladder. So let us try to visualize this problem. So what we have a vertical wall and then we have a horizontal wall and there is a ladder. So this ladder is somewhere here. Now if we apply a kick, this ladder has basically moved and this is the final position of the ladder. So initially ladder AB is this position and now if we apply a kick, then finally this ladder is in position CD. So we have to find envelope. This means let us consider these points of ladder. These points are moving along a line, along a curve. So we have to find equation of that curve. That will be the envelope of ladder. So let us consider any general point. We can consider general point P and the coordinate for P is x, y. So we have to find basically locus of point P. So my problem is basically to find locus of point P. So we have to find locus of point P. Let us say the length of ladder, we will assume length of ladder is 1 unit. And then this angle, let's call this angle as theta and this angle is theta plus d theta. So let us try to find various distances. So this ladder's length is 1 unit. So let's say this is 1 unit and let's call this point is O, that is origin, and this is my x-axis and this is my y-axis. So we can basically find different lengths. So what will be this length? And what will be this length? And similarly what will be this length? And what will be this length? So let us try to find it out. So we have here basically this length is 1 unit. So this will be basically cos theta. So this will be cos theta of that. So this will be cos theta of that. So we can say this length is simply 1 times cos theta. So this is simply cos theta. Similarly, this length will be cos theta plus d theta. Now, similarly, this length will be sin theta. And this length will be sin theta plus d theta. So, this length we can write sin theta plus d theta. Sin theta plus d theta. So, now I know the different lengths. Now we will do some construction. So let us first see, we will make a line that is perpendicular to this x-axis. So this is a perpendicular line. Now if you see these two triangles, that is triangle AC, let's call this point P, ACP and triangle BEP are similar. So these two triangles are basically similar triangles. Similar. So you see this angle is equals to this angle and then you can say this angle is equals to, so let's call this angle as alpha then this angle will be alpha, because this line is a perpendicular to this line and this line is also perpendicular to this line. So this is these two lines are parallel lines, and then one line is intersecting, so these two are alternate angles, so this angle will be alpha. So these two triangles are similar triangles. So if these two triangles are similar, we can write AC by BE is equals to CP by EP. So this is my equation 1. So this length, that is AC, that is this length AC divided by BE. So this length is BE. Let's call this point as BE. So AC by BE is equals to CP. CP is this length, and divided by EP, and EP is this length. Because these two triangles are similar, we can write something like this. Similarly, we can also see, we have triangle CMP. We will make a construction, and so triangle CMP and triangle P and E are similar. What this means? So let us do this construction. So what we will do is, we will make a perpendicular line from E to this line. So this is the construction that we have done, and this length let's call N. This point is N. Similarly, from here we can make another construction. Let us call this as M. So this triangle, that is CMP, and triangle, so this is CMP and PNE. So this triangle is P, and then we have N. Basically, I have to make one other construction. So let's say this line. So this point is N. So this triangle PNE, this triangle, and CME, this triangle, CMP. These two triangles are basically similar. You can verify yourself, because this angle will be equal to this angle, and this angle is 90 degree, this angle is 90 degree. So in this triangle, these two are similar, so we can again write CP divided by EP is equals to MP divided by NP. So that is CP divided by EP. So this is your CP, this length is CP, and this is your EP. So CP divided by EP is equals to MP, that is this length, divided by NE. So this will be NE, so not P. So this is NE. So now we have two equations. So you see, this thing is common. CP by EP here is also there, and CP by EP is also here. So if we basically combine these two equations, we can write what we can write. So we will have this, we will use, that is AC by BE is equals to CP by EP, which is equals to MP by NE. So we will use this expression. Now the different lengths are not known. So we don't know AC, BE. So let us try to calculate different lengths. So we can show the same triangle once again. So this triangle, so let us show this triangle. So let us try to find out the different lengths. So first let us consider MP by NE. So MP is what? MP length, that is this length. So MP is this length, and this length is nothing but x. So this length is x, because the coordinate of point P is x. So MP is equals to x. And what about NE? So NE is here, so E is here, and NE is this length. So this length is nothing but cos theta plus d theta minus x. So this length I can write cos of theta plus d theta minus x. So we will use this, and we can also rewrite mp by ne, because theta plus d theta is, so d theta with respect to theta is very small, so we can also write x by cos theta minus x. So basically we have calculated one term, that is mp by ne. Now we will try to calculate AC by BE. So let us try to calculate AC by BE. So what we have here, we want to calculate AC by BE. So what is length AC? So let us try to find length AC. AC is nothing but this distance, that is sine theta plus d theta minus sine theta. So sine theta plus d theta minus sine theta. So this length. Now if we expand this, so this will be sine theta cos d theta plus cos theta sine d theta minus sine theta. So this will be simply sine theta, and cos d theta, d theta is very small, so this is 1 plus cos theta, and sine d theta will be d theta because d theta is small, minus sine theta. So this is simply cos theta d theta. Similarly, so now we have calculated AC. AC is nothing but cos theta d theta. Now we have to calculate BE. So what is BE? So this length is BE. So if you see here, this length is BE. So what will the value of BE? So to calculate BE, we need to calculate BD, and once I calculate BD, then that I will take tan theta of that, and then I will get BE. So let us first calculate BD. So BD will be nothing but this distance, that is cos theta minus cos theta plus d theta. So this will be cos theta plus minus cos theta plus d theta. And once again, if you expand this, so this is cos theta minus, and cos A cos B minus sin A sin B, and then minus minus becomes plus sin A sin B. And once again, you use the fact that it is a small angle, so this becomes minus cos theta, and this is simply sin theta d theta. So from here you can say this is sin theta d theta. So now we have calculated BD, and then BE is what? BE is nothing but tan theta of BD. So BD times tan theta. So you see here, so this triangle PE is equals to tan theta of BD. So BD tan theta, and BD we already calculated sin theta d theta, and this times tan theta. So this is simply sin squared theta by cos theta times d theta. So we can plug this value here. So we will have sin squared theta divided by cos theta and d theta. So from here you can say AC by BE is nothing but cos squared theta divided by sin squared theta. So now we can plug this value of AC by BE. So we calculated AC by BE. So this term we calculated, and this we already know. So we have this expression. So AC by BE calculated, and MP by NE we have this expression. So using these two expressions, we can solve. So we have MP, the same expression, MP by NE is equals to AC by BE. So this expression. So this expression we have MP by NE, this one is equals to AC by BE. Same thing I have written. Now AC by BE we already calculated this term here, that is cos squared theta divided by sin squared theta. And we have also calculated MP by NE, that is this term, x by cos theta minus x. So this term is x by cos theta minus x. Now you can solve for x. So if you solve for x, you will have x sin squared theta is equals to cos q theta minus x cos squared theta. So if you take x this side, you will have x sine square theta plus cos square theta is equals to cos q theta. So from here you can write x is equals to cos q theta. Now, so we have calculated one coordinate of point P, that is x coordinate. Now you do the same exercise, then you can also calculate the y coordinate, and this will be very similar. So I am not going to the calculation. So similarly, we can find y coordinate, and that will be sine q d theta, sine q theta. So once I know x and y, we can find locus. So locus of point P will be, so let's take x raised to the power 2 by 3, that will be cos square theta, cos q theta raised to the power 2 by 3, that is cos square theta. Similarly, y raised to the power 2 by 3 is equals to sine theta raised to the power sine q theta raised to the power 2 by 3, that is sine square theta. So now if we add these two, x raised to the power 2 by 3 plus y raised to the power 2 by 3, that is cos square theta plus sine square theta, and which is equals to 1. So you see, this is the locus. So what is the locus or envelope is x raised to the power 2 by 3, y raised to the power 2 by 3 is equals to 1. So any point x on the ladder will basically follow this curve. So this is not a circle, this is not an ellipse, it's a different kind of curve. So I say x raised to the power n plus y raised to the power n is equals to 1, where n is equals to 2 by 3. So this kind of curve you have. So this is the envelope. For any point we can find the envelope using this equation, or any look we can find the locus. So I hope you realized how easy this problem and this problem is related to the geometry. So if you like this video, please like and subscribe and share with your friends also, so that I can make some more videos. Thank you so much.